Hello and welcome back to Calculus 1. Section 3.4, product and quotient rules. It's a very short section, 2 formulas. And that's it. First, we need to understand that formulas, the rules for limits and rules for derivatives are not the same. And you cannot take the derivative of product of two functions by working on each one independently. That doesn't work. And I can easily show that, but I'll do that later. I'm going to start with the product rule first. The formula which you must memorize is the formula which says that the derivative of f of x times g of x is f of x times g of x prime. So copy the first derivative of the second plus g of x f of x prime. And that's the product rule. Now, some students like to remember this. Say u is f of x and v is g of x, and they like to think of this one as the derivative of u times v is uv prime plus vu prime. It's the same, it's just less letters. I don't care which notation you're going to adopt and use. All you need to do is to follow the formula. So say you are taking the derivative of x cubed times x to the 8th. Well, clearly you can take this derivative by cheating with algebra, having this as x to the 11, right? And be done right away. So you can. So we have the x to the 11. Oh, the derivative of x to the 11, right? If you want to cheat with algebra, and you have 11x to the 10. But we can also use the product rule to solve the same problem, which is copy the first one, and then the derivative of the second one, which is 8x to the 7, right? Plus copy the second one, which is x to the 8, times the derivative of the first is 3x squared. So this is your f g prime g f prime, if you're following the formula, or uv prime plus vu prime, right? So you see clearly that I just applied the formula. And now you do the algebra over here, so it's 8x to the 10 plus 3x to the 10, together 11x to the 10, and we know it's 11x to the 10 because we used algebra earlier to solve the same problem. So in this case, as you can see, using algebra or using product rule gets us to the same answer. Now you might say, well, why would I? And I say, because. Can you use algebra now? Can you? No, right? You cannot multiply x squared and e to the x. Now this is still multiplication of two functions, so you absolutely must use the product rule formula. Product rule formula says copy the first as is. Again, you have, I hope you guys see two functions, f and g. They are multiplied, right? So copy the first times the derivative of the second. What's the derivative of e to the x? E to the x. We covered it in the last section, right? Plus copy the second, which is again e to the x, times the derivative of the first is 2x. G prime G F prime. If you're having issues with this, please, a block times a block plus a block times a block F G prime, you get the idea. And just populate the blocks until you get used to the procedure of what goes where. It's a formula. There's really not that much that I can help with here. Other than telling you that you must factor, you must be masters of factoring. I can kick out GCF, greatest common factor of xc to the x, which leaves x plus 2 in parentheses. The sooner you get good with these factoring methods, the sooner you can get more comfortable with chapter 4 calculations, where you go and you set this equal to 0, solve equations and all this kind of stuff. So this is not the end of the story. This is just a method to take the derivative, and we are going to use it later. So make sure you are factoring your answers to the whatever is most there. That's the product rule. Really, there's nothing else to it. You will learn the formula, whether you want the top form or the bottom form. Each u and v are functions. I'll put the word or over here. And then the way I memorized this was this little chant that I have. Copy the first derivative of the second plus copy the second derivative of the first. And what are the first and second? Obviously, first function, u, f of x, and the second function, g of x, or v. Copy the first derivative of the second plus copy the second derivative of the first. Half of the lecture done. All we have is a quotient rule left. Oh, let me just write over here, product rule, because I should. Quotient rule. If we have division of two functions, say f of x divided by g of x, then the derivative of this is g of x times f prime of x minus f of x times g prime of x divided by g of x squared. Quotient rule. So quotient rule is obviously more convoluted. And you start copy the second derivative of the first. It's completely opposite from product rule, right? Product rules was copy first derivative of the second. This one is copy second derivative of the first. Product rule was plus, this guy is minus, right? So completely opposite of what the product rule does, divided by g squared. Now there was also something that a student taught me years ago, where they call the top function high and the low function denominator low. So they go low d high minus high d low over low squared. I don't know if you want to sing that or not, but it's available. I can already hear someone trying to vocalize it. That's good. Next class we are going to have tryouts for American Idol. And this has to be the song, obviously. So get some tunes to it. The high derivative of the upper, right? The numerator. I don't like it, but you know, you guys might want to use it. So again, it's pointless to use this on, let's say, x cubed divided by x to the 6. Because again, algebra beats us over here to, you know, simplify everything and then solve a simple problem. So this is not going to be used if you mix something simple like this. But obviously it is going to be used if you have rational functions around, or you mix in trig, or you mix in ln, you mix in e. We didn't cover ln yet, but it's coming. It's also in chapter 3 somewhere. So we have, right, so for something like this, use algebra, right? Use algebra. Now here are the examples. We do 2 examples of where you actually use this. So say you have x cubed plus 9 divided by x squared plus x minus 1. Right? You can't really combine these. You can do long division, but you're still going to end up with the awful remainder over there that you still have to deal with. So you're stuck to use the formula. And the formula simply says, take the denominator as is and square it in denominator. And then write it in the numerator, so x squared plus x minus 1, times the derivative of the numerator, which is clearly 3x squared. The plus 9 goes to 0 on the derivative. Minus copy the top, which is x cubed plus 9, times the derivative of denominator, which is 2x plus 1. At which point you FOIL, combine like terms to get it to the lowest terms. So we have 3x to the 4th plus 3x cubed minus 3x squared. And now you have to FOIL. This is 4 terms here. Note the minus in front, so everything you get, you have to change the sign. So 2x to the 4th plus 18x, so minus 18x. Plus x cubed, so minus x cubed. And plus 18x, plus 9, which is minus 9. There we go. Divided by the same x squared plus x minus 1 squared. Like terms, 3x to the 4th minus 2x to the 4th is the single x to the 4th. 3x cubed minus 1x cubed is plus 2x cubed. Minus 3x squared minus 18x minus 9. Divided by x squared plus x minus 1, everything squared. Yep. Hello, quotient rule. Woo! It's wonderful, right? Find the derivative of 3e to the x divided by x squared minus 1. We can make this the last example for today. Same procedure. Denominator gets squared in denominator. Then we copy it as is in the numerator times the derivative of 3e to the x, which is 3e to the x. Derivative of e to the x is e to the x, and the coefficient 3 gets copied, so it's the same. Minus copy the top, which is 3e to the x, times the derivative of the bottom, which is 2x. What is the thing you can factor? Very good. And what's left? What's left is x squared minus 2x minus 1 divided by x squared minus 1 squared. That's it. You have to plug in the values in boxes a box times a box minus a box times a box divided by a box squared. Right? This is what it is. You have to learn what each box represents and plug stuff into it. So go home and do homework. Right? See you next Saturday. Or if you stop by office hours sooner. Bye.